Greetings, ladies and gentlemen, and welcome to Lesson 10.1, page 412 for the 8th grade general students, and Lesson 16.1, page 712 for the 7th accelerated students. Ladies and gentlemen, our new unit on exponents and scientific notation. We're going to learn a whole lot about exponents. I know you know a little bit already, but we're going to learn a whole lot more in this unit. But we're going to review what you already know about exponents in this first lesson. Today, we're going to apply what we learned to express numbers using exponents and to raise a negative number to a whole number exponent and observe the patterns that emerge. Our essential question, how can you use exponents to write numbers? Now, ladies and gentlemen, I'm going to stop and pause for just a second and remind ourselves exactly the process that we are supposed to use to take notes. This is essential, it's critical, and it really will help you moving forward. So, how do we do it? One, when we first start, we always go to the appropriate pages in the book and we take our own notes first before watching the video. I hope you've already done that. If not, then you're going to pause as soon as I'm done yapping at you and you're going to go do it because it's important. After doing that, when we do the video, your pen, your pencil, your markers are down. You're watching, you're listening, and you're learning. That's the important part. First, then when I'm done explaining, you can then pause the video, pick up your pen, your pencil, your marker, and write down any additional information that you need. That's after reviewing the notes that you took from the book. As we go through the examples, you should again have your pens, your pencils, and your markers down. Your eyes, you're watching. Your ears, you're listening. And you are learning as you're watching Mr. Ross go through these examples. When I get through with the examples, you should pause. Well, I say each slide, because there might be one or two, maybe even three examples on a slide. You pause that slide, because I will give you warning, and then you write down that information from that slide into your notes, so that your brain is repeating what you've just watched and listened and learned about in the process of actually writing it down. I know it takes a tiny bit longer to get your notes done when you do it that way, but really the brain cannot absorb appropriately all the information necessary if you're trying to watch, listen, learn, and write all at the same time at the same speed of which Mr. Ross is going. All right? So very important. Ladies and gentlemen, so you went to those perspective pages in the book and you wrote down some notes on exponents. So let's talk about this. This is an x squared that you've learned about before, and you probably know quite a bit about it already, but we got to get a little bit more specific. So from your notes, you should have learned that this x squared is actually called the power. It is the product of repeated factors. All right? So what does that mean? A product of repeated factors. What is the factor that is being repeated, and how many times are we repeating it? Well, that's how we learn about the parts of this power. And the first part we're going to learn about is called the base. The base is the common factor. So in this particular case, the x is the base. It is the common factor that's going to be multiplied a repeated number of times. Well, how many times are we going to multiply that base x? That's right. That is represented by the exponent. The exponent tells us the number of times the base is used as a factor. So in this particular case, having this power of x squared, we recognize that x squared can be written as a product of repeated factors by saying x times x. Okay? Doesn't help us a lot, so let's change the base. Let's say the base is 7, and I've got this power of 7 squared. You would recognize that that's 7 times 7, and if you were asked to evaluate that, you would then say that that is 49. All right? Pretty straightforward. Now let's think for a second. Put our thinking hats on. What if Mr. Ross asked you to go backwards, or the book, or anything asked you to go backwards and said, hey, I've got these two factors, x times x, and I'm asking you to write this as a power using exponents. That's where you recognize that x is the common base and that there's two of them, so I'm going to multiply it 2 times, and that would be x squared. We've got to be able to go backwards as well. All right? So go ahead and write down anything from here that you need to, and then I'm going to the next slide. So, ladies and gentlemen, remember back to our lesson way back at the beginning of the year on expressions and equations, and the first thing we talked about in expressions was terms. And so x squared is actually a term. So in this term, there is another part of this term that we need to remind ourselves of. It is the numerical factor of this term. Do you know what that numerical factor is? Well, let me give you a hint. If you can't see it, that's right. It's equal to 1. And do anybody remember what we call this? No, it's not the run. That's in a different lesson when we're talking about slope. But in this particular case, I'm going to put a numerical factor on here and see if it helps you. In fact, I'm going to put a 5. So now I have this 5x squared. Do you remember what the 5 is now called? Oh, some of you remember. That's right. It's the coefficient. It's the numerical factor of the base. In this particular case, the base of x to the power of 2. So now if I ask you to write this 5x squared as a product of repeated factors, how would I write it now? Well, I'm going to tell you. 5 times x times x. You got to understand that this exponent only applies to whatever it is attached to. And it's only attached to the x. It's not attached to the 5. So in this particular case, I'm multiplying 5 times the power of x squared. Notice I didn't take my green power symbol and move it over to include the 5. Now, some of you might be thinking in your head, well, could you? Yes, you could. And in mathematics, you would just have to write that differently. There's a different designation if I want to raise that 5 to a power of 2 as well. There's a couple ways I could do it. I could make 5x the base by putting it inside parentheses. That means I'm including all of that with a power of 2. And this right here would be 5 times x times x. All right. The other way to do it would be to write the exponent on each one and go 5 squared x squared. That also would be equal to 5 times x times x. All right? Go ahead and write down any of that, and we're going to get busy with some examples. So the first thing our examples are asking you to do is go backwards. That's right. Write the product using exponents. We're going to write these powers, and we're going to use exponents. All right. And then our example number 1, we have 4 times 4 times 4 times 4 times 4 times 4 times 4. We recognize we have a repeated factor. That common factor is 4. And we should also recognize that there are 7 of them. And so 7 times, if I'm writing this product using exponents, I can write that as 4 to the 7th power. All right? And example number 2. Here I have negative 2 times 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 x times x times x times x. All right? Well, in this particular case, I have 1, 2, 3, 4, 5 of these negative 2's. So I have to actually do that one separately because I have negative 2 5 times. And the x is only 1, 2, 3. There's only 4 of them. So I would have to write these separately as negative 2 to the 5th times x to the 4th. Okay? If there were 5 of each one of them, I could actually do it a little bit differently. And we might see an example of that in class. Ladies and gentlemen, I'm going to move on to the next slide, so you need to pause. Example number 3, we're now going to evaluate each expression. So here in the example 3, we have 4 squared. So 4 squared is equal to 4 times 4, which is equal to 16. Don't need to spend a whole lot of time on this, I'm sure. Our example number 4, negative 4 squared. Ooh, we might need to spend a little bit more time on this one. Remember what I just said a moment ago about the coefficient of the base. What is the coefficient of the base in this one? It's negative 1. Is that negative included? You might have had an elementary teacher that told you that this was negative 4 times negative 4. Wrong. No bueno. This is actually negative 1 times 4 times 4, which equals negative 1 times 16, which equals negative 16. If I want that negative included, I would have to rewrite it to be included as part of the base. Now this particular example, number 5, the product of negative 1 times 4 is now being raised to the power of 2. So this would be negative 4 times negative 4, which would equal a positive 16. So important to recognize and understand the difference, ladies and gentlemen. Okay? Make sure you pause the video and write this down and join me for our next examples. Our last two examples are using order of operations that involve some powers in them. And in example number 6, 7 plus negative 2 times 3 squared. So we have to use our order of operations. If you remember GEMDAs, and GEMDAs being groupings, and then you have exponents, multiplication, division, first left to right, addition, subtraction, first left to right. In this particular case, our parentheses is nothing more than designating the difference between adding a negative 2. So the first thing we have to do is the exponent. So we're going to have 7 plus a negative 2, and of course 3 squared, that's 3 times 3, which would give us 9. All right. And now as we move along, 7 plus a negative 2 times 9. What are we going to do first? That's right, we're going to multiply first. So we would have 7 times, 7 plus negative 18. And of course, using our rules of integers that we learned, we're adding opposite signs. So we subtract 18 minus 7 is 11. And the negative 18 is larger. So this equals negative 11. Our next example, oops. I always hate it when that happens. I'm going to slide this out. So if you need to, pause and write it down first, and then, or back up, and then write it down before we go to this one. So example number 7, we have the absolute value of 1/3 times 2 cubed minus 10 squared divided by 5. Oh my, there's a whole lot going on in here. So first thing I'm going to do is go inside the grouping symbols of the absolute value. It says I have to do everything inside that first before I can do the absolute value. And inside that absolute value, there's another grouping symbol. And inside that is 2 cubed minus 10 squared over 5. So we're going to do a couple things at the same time. I'm going to bring down my absolute value bars in 1/3. And I'm going to bring down my parentheses, and I'm going to bring down my other absolute value. Now I can do this right here because it's separated by a subtraction sign. 2 cubed, 2 times 2 times 2, that's 8. Minus 10 squared is 100 over 5. All right. Now I'm going to go further. And I'm going to bring this down 1/3. The absolute value of 1/3 times 8 minus, well, 100 divided by 5. Anybody? That's right. It is 20. And I'm taking the absolute value of that. And then I'm going to do 8 minus 20. So I'm going to come over this way. 8 minus 20, I've got the absolute value of 1/3 times 8 minus 20 is what? That's right, it is negative 12. And 1/3 times a negative 12, we're just going to keep moving right along here. The absolute value of 1/3 times a negative 12 would be negative 4. And lastly, the absolute value of negative 4 is 4. You can copy all those down, ladies and gentlemen. And we are pretty much done with this lesson, this set of notes. I know it was one set, took kind of long. We're almost done. Make sure you write down any questions you have regarding exponents. Do any marking you need to so you know what to ask about. Make sure your notes are complete with quality. All these other things, attitude and effort, aggressiveness. You can put in a max 45 minutes in each night. Please be accountable. Please build your character and your intelligence. And our quick write for tonight, there are 3 of them. I already included them in your notes, so you don't have to write them down. They're already there. You're pretty much done. Complete those. We'll talk about them. We'll answer any questions you have tomorrow. Thank you for spending your time with me. I will see you tomorrow.